YouTube the recording. Okay. Okay. So, but can you join so that you can? We will have a. Today I'm thinking like this. Open your Lentera. There are 3 slides there. Okay. And then you will also read. Help me to read. Can you? So our goal today is to study about 3 things. I think we already finished the concept and assumption last meeting. Today's discussion is about generalization, fallacies, and if we can finish, we can continue with the accuracy and something. Okay. Hi there. You can Lentera.
What, mister?
Yeah, you can open Lentera and then get the slide about generalization, okay, fallacies, and then accuracy and something. Okay, let's start with generalization. You're in, you don't need, when you are online, real online like this. Camera. Yeah, you, morning. Everyone here? Good. Okay, so let's start. Yeah, you're here, so you don't need to. I can see you. But yeah, online, so you need to have some sort of the others can see you. Okay, so let's start with generalization. Can you? Okay. In this lesson, you will learn about generalization and faulty generalization. Okay. So, what is generalization? It's a statement of relationship between 2 or more concepts. We discussed concept last meeting, right? So, in this case, generalization is defined as a statement or an idea that applies to a group or people or things. So, generalization is not always bad. We need to do generalization to abstract things of several concepts. It's actually a good thing. Okay? But there are what is called unwarranted generalization or faulty generalization, okay, with this logical fallacy. So, and we can see this in our society, for example, in Indonesia. This is a common practice to have faulty generalization. Okay, so generalization of itself proceeds from the premise about the sample, a small cases, and then they conclude population. Okay? It can be correct only if we use actually the statistical representative sample. Okay? So, I mean, the technique of generalization from sample to population can be correct, not necessarily wrong. Okay? So, let me draw. Okay? So, say you have a sample. Okay? And this is the whole thing is the population, right? So this from this population you get a subset of this small part, okay? And this is your sample. Can you see it? Okay. I did not share my screen. Oh, sorry. Okay. They did not tell anything.
Oh, I opened it on my phone, the slide.
Okay. Okay. Now, can you see it? Okay. So, suppose you have a let me draw it. Okay. And then this is suppose your population, and you get certain sample here, small here. So I zoom it, it become a sample. See that? So you want to say something about that population. Okay? For example, what is the height of human? Okay? The height of human. So, of course, the height of human can be maybe 140, okay? 150, 160, 170, 180, maybe 200 centimeters. Is that correct? Is there any, I mean, adult human. Is there any adult human that actually below 90? Well, probably there is, but rare, right? So we can say there is a kind of distribution, right? So this is called frequency. The vertical line is the frequency, how often it is, and the horizontal line here is the value, for example, the height. Okay? So of course, on average, probably around say 160. Okay, some people can reach 210. So some NBA player, basketball player, 220. So there are some probably around 90. Adult. We're talking about adult. So of course, children is. At the same time, we can see the ring, and then we will say, okay, this is the this distribution represent the characteristic of the population. But how do you know? Of course, what we do is actually taking the sample, isn't it? We look at our surrounding, right? And we probably collect certain people, okay? A few people, and then from there we get the sample. Okay? So if our say I will take the mean, yeah. So the mean is probably I call it mu. Okay. So and I take the sample here, and I take the average. I call it x bar, right? So then if my sample is correct, if my sample is correct, what is the meaning of correct? Correct means representing the population. Right? Then my x bar must be equal to mu, isn't it? Right. So this will only happen, okay, if you take the sample not from one place but from many places. So taking a random sample, okay, in the population, that is what is we call here statistically representative. But for example, you are in the small community, you only take the sample among your family members, okay, among your friends, okay? Which of course uh, uh, not statistically representative of the whole population. Okay, then your mu is not the same. Your so, but if you conclude that because they are not the same, but you said you're insisting, yeah, you're saying that no, my sample from my observation represent the whole population, then that becomes false generalization. Is that clear or not? Okay. We have so let's say here. So we have fact, okay, and generalization. So fact is based on observation, right? Generalization is also based on observation, but it creates an inference or suggestion based on a small sample toward the whole general population. In terms of data, okay, part is based on data, but generalization is to show the relationship between or among the concepts in the data. So in itself, it can be correct, can be good thing, but it can be also a bad thing. Okay, so now I want you to read one by one. Okay. So who first? Dave, you first.
Members of families help one another.
Members of family help another. Is this generalization? Well, not always members of family help one another, but this statement is generalization. Okay. Next. Yeah. Man influences his environment and is influenced by it. Okay. So why this is generalization? Is this correct or not? Yeah, it can be correct, right? But it can be wrong. Right? So it's generalized reason. So tell him. Many people have contributed to our personal civilization. Again, this is an example of the barista. Yeah. So, based on observation, someone will say, make this statement. Dave, next. Dave.
Basically, all people are very much alike.
No,
Also,
no, no.
I did. Oh,
Barista
okay.
already there.
I did not hear
You did
the.
not hear.
Yeah.
Okay, so here, the one in
Man lives in a continually changing world.
man live in a continually changing world. Okay, here again. Oh, this can be generalization, but can be real fact, yeah? Because this already said in our neighborhood. So this is clearly a good thing. Okay, next, new invention leads to change the way of thinking. So this is like common thing, right? You always see this. You know that this is generalization. Okay, so let's start. Condition. Uh, the last one, the date.
Peoples of the world are interdependent.
People of the world. This is clearly generalization. Yeah? So not everyone, right? But it said everyone. How about this? Next. Yeah. Correct. So there are three concepts there, okay, that put together. Okay. Next. Trees have growth rings. Right? Continue. So this is a generalization that becomes not. This is correct. Isn't it? Oh, next. Who's next? Dave. Okay. What is it? Well, you learned that in physics, right? Yeah. What? Not necessarily. There are now small, very small matter that not necessarily have mass, right? Like electron, proton. A proton have mass. Electron have mass? Yeah, probably. Oh, I don't know. But do they have volume? Anyway, so, who's next? Dave?
There is a relationship between an object's volume and surface area.
Surface area. So, so all of these are example in physics, right? Can I continue with the next slide? How about this? Hmm. Okay, so this is again from physics. Okay, and you probably read this in the paper, but you know this is actual generalization. So all conclusion, okay, either generalization or deduction. So there are two ways of concluding from the fact that you see. Okay? One is to generalize, and the other one is to make it more specific. So population will increase with the surface area and more content will increase. Okay, so here are the indicators, okay, for generalization. Okay. You can see the word all, always, every, everyone, okay, few, many, most, never, none, and usually. So these are the common words to distinguish that this is actually generalization. Okay. So can you give an example? Okay. Can you give example of generalization?
Mm,
Okay.
every mammal gives birth.
No?
Every mammal gives birth.
Every mammal gives birth. Okay. Is that the generalization or definition? Is there any mammal that don't give birth? So, oh, many children is many children needs. Oh, many children eat cereal for breakfast. Oh, okay. So, or you can say uh, all children or something, or most children. Okay, so that will create more generalization. So, okay, all teenagers drink their phone. So, all people like candy. It's not necessarily true, but it's generalization. Okay, very good. So, next, let's discuss the negative side of generalization. Okay? So, this is other name. Okay? Sometimes we call it hasty generalization. Sometimes we call it faulty generalization. If you watch movies or you saw it in the court, they will not say faulty generalization. They will say You're jumping into conclusion here. Okay, when they say you are jumping into conclusion, that means there is a fault determination. Yeah. Same thing with you can say inductive fallacy or fallacy of deductive conduct. Okay. So Mark Twain telling that all generalization are false, including this uh, show, including this one. Okay, so uh, often generalization is not entirely true, okay, because there exists counterexample of individual or situation when the generalization does not apply, right? So in this respect, faulty generalization can be similar to stereotypes, okay, that they sometimes very offensive. Uh, Drawing conclusion about all or many instances of the phenomena that has been reached, eh, on the basis that one or few instances of that phenomenon is called faulty generalization. Okay? Because okay, the sample is too small, okay? Or maybe unrepresentative. Okay? Uh, I give you an example. Oh, you're Chinese, so you must be very good in math. This is faulty generalization. Or, oh, you are Chinese, so you must be very rich. It's again faulty generalization. And that makes a lot of people suffer because, oh, you are woman, then you must be something. It is not necessarily true, but they create faulty generalization. Okay? And this fallacy occurs when we make generalization on basis of insufficient evidence. So learning that you know this is faulty generalization, okay, when you face this, then you can say you are jumping to conclusion. Or that's faulty generalization. You simply say, then make the people realize their fault, okay, in making the statement. Okay? There are certain anecdotal evidence uh, with this factual claim, yeah, relying only on personal observation that they collected casually, yeah, non-systematic manner. So this is an example of so last Monday I read my part. So the Monday before I broke my furnace. So then his conclusion is bad things always happen to me on Monday. Okay, so but luck is faulty generalization. Okay? So again, this is jumping into conclusion. This one report from two cases. Okay? Now can you give example of this? They
Uh, Asian people have small eyes.
Asian people have small eyes. Not necessarily true. Yeah, that's faulty. All Chinese people can speak Mandarin, but you don't. Okay, so. Okay, go. I can hear you. Store. Oh, store. All Chinese people own a store. Okay, no, but not necessarily. Okay? How about you? Oh, Chinese people are very religious. So again, this is not always true. In general, probably true. Okay, so there are superior average of certain group. that imply the individual members of the group must be superior. Yeah? The same thing, uh, certain race, certain religion, certain culture are part of superior. Again, they are false generalization. Okay, and if you said, "Oh, you graduate from Harvard, you must be very smart," right? Not necessarily true. There are some idiots there also, right? So, uh, so if you graduate from certain university, you must be excellent or you must be bad. Okay? So judging, okay, labeling people based on good or bad, okay, this is common mistake, and this is false generality. Okay, let's read this one. So who will start? Okay. This is it. Okay. Sarah? Oh, every salesman lies to make money on the sale. False generality. Homework is very easy. Okay, Dave.
Um, Homework is very hard.
Homework is very hard. Again, whether it's easy or hard, both are false generalization. Okay, so uh, police officer are corrupt or police officer are heroes, the same, yeah. Okay, whether it's good or bad, again, false generalization. Okay. Next, all criminals have troubled background. Okay, all criminals can be rehabilitated. Again, not necessarily. So, can you see there are certain probability? Can you see the characteristic of false generalization? Okay. All lawyers are proof. Right. Okay. I think because I'm using this one, so there are some fiber that maybe coming. Okay, so these are the again false generalization. So all Chinese are rich, okay, so and so on. Okay. So you can read by yourself. Okay, all these too many examples that I provide here to show that this is false generalization. Okay. All women want have large family. Okay, all men are afraid of commitment and so on. Is that true or not? No, right? So, yeah. Okay, so uh, can you explain, okay, how are you going to face the faulty generalization? If someone tell you, okay, that you know this is actually faulty generalization, so how are you going to do it? Based on your experience. That's okay. Oh, yeah, who will start? Kalista. So, have you ever being discriminated? Maybe because you are young, maybe because you are a woman, maybe because you are certain religion or certain race. Hmm. And how are you going to do about it? Anyone? She needs time to think. Ellie, please. Oh, you are tall, so you must be a basketball player. And then, hmm, so that's a positive thing, so that's no problem. Right? So you just simply reject that. Yeah, right? Uh-huh. Mhm. Oh, okay. Okay, so you were born in Indonesia, but you're an American. Okay. So are you ready? Okay, go. Okay. 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 Dave, tell your opinion.
Um, I wear glasses, so that means I must be a nerd.
You must, you wear glasses and you must be a nerd.
Yes, I just have bad eyesight.
And
It's
then
very
how do you
distressing.
do about it?
I did nothing.
You did
I
nothing.
just laughed at them. Yeah.
You just laugh. Okay, so my question to you before I close this topic, what is generalization? Do you understand what is generalization? Yes. Do you know what is what is generalization? Right? Let's go to the next one. So this is a lot of readings. Okay, let's start with this. So fallacy. Okay, so this is the negative. So this is logical fallacy. Okay, so you will learn most common fallacies, and I hope through this you will be able to identify or recognize them. So what is fallacy? Okay, so incorrect inference. So this is called fallacy. So in logic, if the argument is false, this is also sometimes called fallacy. Okay? So a fallacy is a defect in the argument that consists in something other than merely false. So it comes from the word fallacy in to deceive, to lie. So by learning fallacies, okay, if you can detect the lie, okay, I hope you don't use this to lie. Okay? So why fallacy happen? Okay? First problem is mistake in the argument. Okay, so this is called formal fallacy. Okay, the second problem is actually the content, the semantics. So the actual truth or falsity in the premises, or there are certain degree of relevance, or the effect. Yeah? The effect is actually so the effect of suppressing the evidence. So they reduce the information. So then we can categorize fallacy into two. One is called formal fallacy. How do you know that? Based on the form. Formal in here is the form uh, of the argument is not correct. The second one is informal, yeah, depending on the content. Okay. Now, uh, now we are in the informal fallacy. The formal fallacy we can detect easily. We just check the form, the format. Okay. I think yesterday during the discrete math, I gave a few one or two fallacies. Okay, that actually you can see the form is incorrect. You can prove it. Who did that? Is that you? If P, then Q. Then you prove it. This is contradiction. Okay, so that is an example of formal fallacy, okay, that will lead to contradiction. Okay. So in this slide, I'm talking about the informal fallacy. So informal fallacy is depending on the context. Okay, so yeah, let's discuss the formal fallacy first. Okay, so formal fallacy occurs when we misapply the valid rule of inference or else follow a rule which demonstrably invalid. So this is an example. All bullfights are monstrous rituals. All executions are monstrous rituals. Therefore, all bullfights are. This is you can put this into a form. Okay, all bullfight is all three. Okay, it's three and so on. So then we can see that this is actually incorrect. So all P are Q or R Q, right? So then it is you see that this is the conclusion is all P are R. It is not related, right? So this is clearly it's detecting by the form. You know that this is clear, right? This is clearly okay. So the correct one is yeah, all P are Q, all Q are R, then all P are. Yeah, this is the transitivity is. Yeah. Up to here, is it clear? So let's take another example. Okay. If apes are intelligent, then ape can solve puzzles. Okay. Apes can solve puzzles. Therefore, apes are intelligent. So is this correct? No. Why is this incorrect? Why this is incorrect? It's important logical form. That often happens. Okay? If P, then Q. Okay, and then the second premise is Q, and then the conclusion is P. Why this is incorrect? Right? The second premise is F can solve puzzle, which is Q, right? logically, why this is wrong? Because if P then Q, it doesn't mean that if Q then P. Okay? Implication does not mean by implication. Implication does not mean equivalent. Can you see that? I will write it here. So if P, then Q. Okay? This is not if P, then Q. This is totally different. Can you see? This form, yeah, is the same as if P then Q and if Q then P. This is called equivalent. Okay. Well, in here, it's only one way, right? So, but the deduction is now I know Q, right? They want to deduct P, which is incorrect. One direction from P to Q, but it said from Q to P. That's why it is. Okay, can you follow? Clear or not?
Clear.
Yeah. Have you understand this or not? Ask question if you don't understand. Yeah. Okay, I will repeat. Good. So, people often think that if A or if P then Q, people often think if P then Q, then automatically if Q then P. This is logical fallacy. Okay, let's give normal example. Okay, let's use this example. So if are intelligent, then ape can solve puzzle, right? So if ape can solve puzzle, then apes are intelligent. Is it true? It doesn't say that. Okay? It doesn't say that. So then it doesn't mean that if ape can solve puzzle, that doesn't mean that ape is intelligent. Can you see that? Okay. So many people are doing this. Okay. They have only if then. Okay. They conclude then if. Okay. This is, can you detect? This is a very clearly. Uh, this is called hypothetical syllogism. This fallacy is called hypothetical syllogism. Okay. So if P then Q does not mean that if Q then P. Important, yeah. Good, right? Yeah. Uh, ah, so what is the correct form? Okay. A while ago, we said if P, a while ago, the invalid form is if P then Q, and then here is Q, right? So here, the correct one is if P then Q, okay, then you're supposed to give P. Okay, the answer is Q. This is correct. But if you said Q imply P, this is in clear. Okay, so next is informal. This is called circular reasoning. Circular reasoning is a fallacy assuming what we are trying to prove. Okay, so this is a very old way. Okay, so there is a Latin word for that. Okay, sometimes called petitio principii. Okay, or sometimes people say, "I beg your question," begging the question. It is happening when the argument, okay, assumes its own conclusion. Okay, okay. the argument is always valid and not lacking of relevance. Okay? So if all the assumptions happen to be true, then the argument is actually false. Okay? But it is useless as a means of proving a conclusion. So let's give an example. Public nudity is immoral because it is just plain wrong. Okay? So can you find the premise? The premise is public nudity is wrong. Right? The conclusion is public nudity is immoral. So the two sentences basically the same thing. Right? So in that case, the conclusion and the premise are actually the same proposition. So it is way of reason. Regardless whether they are correct or not, it doesn't matter. Okay? But the way to reason is incorrect. Is it clear? Why? Because it's circular reason. This is like if P, then P. Right? If proposition, then the same proposition happens. So can you see this mistake in the argument? Can you read it? Anyone want to read? Okay, go ahead. Justify. Okay. So what do you think? Whether it's true or not, it doesn't matter. But look at the way they make an argument. Okay? Look at the way it creates the argument. Okay, so this is how we make the analysis. Okay? Number one, capital punishment is justice. Right? Number two, for our country is full criminal who commit first act of murder and kidnapping. Okay? And then number three, this is the conclusion to both. It is perfectly legitimate to punish inhuman people by putting it to death. So what is this? The conclusion is the same premise as number one. Right? So 1 plus 2 become 1 again. It is closer. Right? So in this case, this is a circular reasoning. See? By putting each sentence, okay, and look at the meaning of each sentence, whether they are the same or not, then you can see whether they are circular reasoning. Is this helpful? Yes. So the next fallacy, okay, which is also often happen, is called fallacies of relevance. Okay. The fallacies of relevance occur when the premise of the argument have no bearing upon it. So in addition, fallacies often involve a distinctive element which divert the attention away from the very problem. Okay. So most fallacies of relevance occur in an argument that are invalid, low inductive probability. So let's take example. I abhor the idea of infinitely powerful creator. The conclusion is God does not exist. Okay? So one like or dislike is an opinion, not fact, isn't it? So it has nothing to do with the actual existence of something. This premise is hardly relevant. Okay. So now, because this is so often happening, okay, people start to uh, make categories, okay, make categories of the fallacies of relevance into depending on the context. Okay, what kind of relevance here? So let's go And these are in the mostly in Latin name, right? So ad hominem, ad baculum, and so on. So you can start to see. Oh, this is very good in the testing in the exam. So anyway, all my exams are open book, so you don't need to worry. Okay, but you need to read it. Okay, so what is ad hominem? Okay. Ad hominem argument try to discredit, okay, a claim or a proposal by attacking its opponent. Huh? Okay, so instead of providing the reason about the proposal itself, so the meaning of ad hominem means against the person. Okay? Have you seen the debate in politics? Usually, often they do like this. Huh? So ad hominem, it have also several variations because this is so often happen. Okay, they also have several variations. So we have what is called ad hominem abusive, a fallacy by guilt of association, uh, to tuku has the interest and circumstantial ad hominem. Okay, can you see the? Let's go more detail. Huh? So the first one, okay, this is ad hominem abusive. When you see the three diagram, we are in the fallacies of irrelevant, right? And then some of these are fallacy of relevant, including all of this. And then we are now in the ad hominem. Inside ad hominem has several categories. So this is the sub category. Clear? Okay. So ad hominem abusive, okay, is uh, attacking the person A, the character, okay, the family, the gender, ethnicity, okay, or social economic status, okay, the personality, the appearance, the dress, the behavior, okay, professional, politics, religious population. Okay. So the implication is there is no reason to take that person's view seriously, okay, because of their background. So again, if you notice this, you know this is ad hominem abusive. Okay, so let's take example. Jones advocate, okay, fluoridization in the city water. So they want to add fluoride in the water, okay, to improve the teeth. But look at the second premise. John is convicted thief. Okay? So conclusion is we should not fluoridize the city water. Right? Is there any relevance between he is a convicted thief and the fluoridization of the city? No, right? So both premises are true, right? But the conclusion is false. Why? Because irrelevant. If you put it into uh, formal logic, it is can be correct, right? But the meaning matters, not just the form. Okay. Why? Because P2 is actually irrelevant to P1. Okay. Okay. How about this? Is this ad hominem? Yes or no? So John said he saw my clients commit a crime. So this is in the court, right? And P2, premise number two, John is habitual drunk. Both statements are true, right? The conclusion is false. Why? Okay, because again, ad hominem. Yeah? No relevant. P1 and P2 are not relevant. There is no connection. Tidak berhubungan. Okay. So In Japanese, we say kankenai. Anyway, so it's a borderline. Okay? So the relevant in this case is not extremely strong or direct because John's observation might well be taken in place when he was troubled. Okay? So the word so here is also right. Next. Okay? How about this? John say he saw my client commit crime on the night of April 21. John was so drunk in the night of April 21 that he was incapable of observing the event afterwards. Thus, John's testimony about this event is unreliable. Is this ad hominem? Yes or no? What do you think? No, right? Okay, so the premise are true. Okay, the argument present good reason to discharging the witness testimony. Okay, so there is no ad hominem fallacy here, right? Okay, next, fallacy by guilt of association. This is again ad hominem. Okay. So the fallacy of guilt association is attempt to repudiate the claim by attacking not the claim of the proponent, but the company, the friend that he or she kept. Okay? By questioning the reputation of those whom he or she agrees. Okay? Group by the group. Example again, okay, don't advocate politicization of the city of supply. Premise two is the one. So John spent much of his free time hanging around the known criminal, drug addict, and okay. So the conclusion is we should not politicization. So again, these are irrelevant to the conclusion. Okay. His friend may be detestable, okay, but his advocate may be okay. Guilty by association. So you are guilty because of your friend. That's what happened also in the Bible. Okay. Jesus was accused, right? Because he is the friend of the prostitute. He is the friend of the tax collector and stuff. Okay, next one is again ad hominem. This is called you two. You two. You two. Okay. So you two argument attempts to refute the claim by attacking the proponent on the ground that he or she is hypocrite. Okay. Uphold the double standard of conduct or is selective. Therefore, inconsistent in enforcing the principle. So the implication is that the arguer is unqualified to make the claim, okay, and there is no reason to take the claim seriously. Yeah? You see how people are attacking other people, okay, in many ways. One is to use this YouTube. Let's take the example again. So don't believe he should abstain from liquor and don't have his habitual consumption. So the conclusion is very funny. He should not abstain from liquor. So you can see that John's action have no bearing to the truth or falsity of his belief. Okay? Even though he holds the belief of hypocritically, okay, the argument is clearly coming from due to fallacy. Okay. Another way to attack other people is this is very common. So vested interest. Vested interest argument attempt to refute a claim by arguing the proponent are motivated by the desire to gain something or to avoid losing something. Okay. There are many experts trying to trying to analyze something based on that vested interest. Okay? The implication is that uh, that when it not for this vested interest, then the proponent claim would hold a different view. Okay? Hence, we should discount the argument. So let's check the example. Don't support decision bill pending in the Congress. He does so because he owns a major decision firm, which will reap huge dividends if the bill passes. So then we should not support this bill. Well, look, both premises are probably true, but the conclusion is not. Right? Both premises are true, okay? But the way we infer is incorrect. Why? Because they have no relevance. Okay? Look at this example. I make it very extreme, like, oh, you are you're having traffic in Surabaya, traffic congestion in Surabaya, because there are a lot of cars in Jakarta. Right? The same thing, right? No relationship between the two. So this is what happens. Okay, so the next ad hominem is circumstantial. Okay? Circumstantial ad hominem fallacy is attempt to refute the claim, okay, by arguing how by the proponent endorsed two or more conflicting propositions. Okay? Therefore, we can safely disregard one of those propositions. So this is again based on the circumstantial. Let's take the example. Right? John said he abhor all form of superstition. Okay? And John always say that breaking mirror brings bad luck. Therefore, okay, uh, there probably something superstition at all. Okay, the two premises are correct, but the conclusion is no, right? Why? Because it's just circumstantial based on the events only. Okay, so John's claim, whether it's consistent or not, have by themselves no bearing to the truth of the conclusion. So there is no connection to the conclusion. So, okay. Now, this is not ad hominem. Be careful. How do you know this is the number here? Okay. So this is another fallacy, but this is not ad hominem. A strawman argument attempt to refute the claim by confusing it with the less plausible claim. So this is called strawman. So then attacking the less plausible claim instead of addressing the original issue. So strawman argument may in fact provide good reason against the less plausible claim that it confused with the real issue, that this reason may be irrelevant. So again, we are still under fallacy of relevance. Okay. This is an example. There can be no truth that is everything is relative. Okay. Einstein's theory of relativity cannot be true. Why this is a Roman fallacy? Okay. The premise is completely irrelevant to the conclusion. Okay. Why? Because they have lack of knowledge. A lot of conspiracy theories bring because of this kind of argument. Okay? So they don't understand the meaning of Einstein theory, okay? That everything does not actually assert that everything is relative. Okay? So the claim that everything is relative is a straw man. Okay? Okay? So, and then the argument implicitly attack this straw man rather than examining the Einstein absolute theory. So, thus, even if the premise is true, it is actually helpful, then you can see that the conclusion is incorrect. There is no support to the conclusion. Okay. Okay. So, this is another type of fallacy. Right? So, look at the number. Okay. So, this is called ad nauseam argument. Okay. Ad nauseam argument attempt to establish the conclusion by threat or intimidation. So, other name is appeal to force, appeal to the stick. Okay. If you don't vote for me, Mr. Jones, I will tell everyone that you are a liar. Okay? The conclusion is you ought to vote for me. So there is a coercion, yeah? There is a threat, intimidation. Okay? That, in this case, the reasoning is clearly illogical. Okay? Fallacy means illogical. Oh, what do you think? Is this fallacy a problem? There is a threat here. Okay. The father will say, clean up your room or else. And then the child will say, or else what? Or else you will get spanked. Okay. So this is no argument. So this is not okay. This is just an ultimatum. There is no conclusion. Okay. I never tell anything to support the conclusion. So this is not argument. So because this is no argument, so there is no fallacy. Okay. So if only a threat does not mean it is a fallacy. How about this? Okay. Again, look at the number. Okay. So this is called Kundiam argument. The meaning is appeal to the authority. Okay. It will occur when we accept or reject the claim merely based on the prestige, okay, the status, the respect, okay, of the proponent or the opponent. Okay. Say here, my teacher said I should be proud to be a Muslim. And the conclusion is I should be proud in Indonesia. When it said my teacher said, okay, so this appeal that without further evidence that the teacher's statement is correct or justified, the premise is simply irrelevant. Okay, so saying something doesn't make it so, no matter how eminent the teacher is. Okay? Okay, how about this? Is this argument commit a fallacy appeal to the authority? Yes. My teacher say the same thing. I should be proud to be an English. Then premise two, be careful that. Okay, but premise two said everything my teacher say is true. Right? So the conclusion is I should be proud of religion. So in this case, okay, what's the difference with earlier? The second argument, right? The second premise. Okay. So if the second premise is correct, then what? Okay. is relevant. So, okay. So the second premise can be hardly true, okay? But okay, the argument is not correct, but this is doesn't tell that this is actually commit the fallacy of the appeal. This is still fallacy. This is not fallacy of appeal to the authority. Is it clear? Okay. Okay, how about this? We know the actor Kevin Costner urged us to buy a new phone. Therefore, we should buy a new phone. So a lot of advertising is doing this, right? So they bring up for actress, okay, or famous influencer, correct? So basically, the marketing strategy is the fallacy here. So I'm teaching you how to lie. But you know, this is actually incorrect. Okay. So yes, so the argument of this testimonial session of the fallacy is still the same. Okay. Again, the premise has no relevance to the conclusion. Okay. The influencer of the authority in this case does not have any relation to the endorsed product that they endorse. Okay. So important note, many occasions when the appeal of authority is justified or else unavoidable. Okay. So this appeal is not fallacy, provided there is a good evidence that the authority themselves have adequate justification. So appeal to the authority are malicious if the demand and critical acceptance, okay, of the authority pronounced without providing evidence on the authority's reliability. So this is an example that this appeal is not fallacy. A few of us know enough physics to verify this equation of Einstein, right? So without require mathematical and experimental background to confirm it, it's certainly reasonable to take Einstein's word. So the next fallacy, again, you check the number. Okay, so this is called ad populum argument. So appeal to the people. Appeal when we aim for conclusion merely on the ground that most people accept. So when everyone accepts it, does not mean it's the truth. Okay. Example: everyone believes that premarital sex is wrong. Therefore, premarital sex is wrong. So the argument failed to establish any relevant connection, okay, between the premise and the conclusion. Okay. Regardless whether this argument is correct or not, okay, this is called ad populum. How about this? The next one. Okay. Oh, the winning. Okay. So ad mystery convenience. So appeal to pity. As to excuse or to forgive the action on the ground of extenuating circumstances. Okay? The seek clemency of breach of duty or sympathy for someone whose poor conduct and non-compliance with the rules, okay, that is already established. Okay? So appeal to pity may either legitimate or fallacious, depending on whether or not the alleged extenuating circumstances are genuine, relevant to the case or not. Okay, so not necessarily always wrong. You can check. Okay. For example, oh officer, you see my baby here was crying for some candy, and I took her to the candy store before I come back to the car. Okay? Therefore, you should give me a parking ticket. Okay, so okay, so this is called ad misericordiam. Okay, mystery means you need to pity me, ad mystery. So ad misericordiam fallacy. The arguer appeal to the officer pity. Okay, but the appeal is clearly irrelevant. Okay, so there is no reason not to get the king picture. Oh, another another type, okay, number 11. So ini is called ad ignorantiam. Okay, so for appeal to ignorance. This is the form is like this. It has not been proved P, thus P. It has not been proved P, thus not P. So either one of these is the form. So example. No one has ever proved that God exists. Right? Therefore, God does not exist. Or no one has ever proved that God does not exist. Therefore, God exists. It's the same thing. Okay. So both are follow suit. Okay. Appeal to the ignorant. Okay. Nothing about the existence of God follow from our inability to prove God existence or non-existence. Uh, One thing I want to say about God, you remember this. You can only prove existence. Okay, write it down. You can only prove existence. You cannot prove non-existence. Okay? When George W. Bush telling to the Iraq, why you have a weapon of mass destruction, okay? And he never proved that, right? That's clearly a lie. So because why? He asked Saddam Hussein at that time to prove the non-existence. So you cannot prove non-existence. You can only prove existence. Clear? So even the U.S. president is making a fallacy in his speech to attack other nations. Okay? So another one, number 12. Okay? This is called uh, ignoratio fallacy or missing the point. Okay? This occurs when the premise of argument warrants a different conclusion from the one argument. Okay, let's take example. Okay. So say A and B are debating about the law. A said, does the law allow me to do that? Okay. And then B said, the law should allow you to do that because of this. Okay. So in this case, B missed the point. Okay. The question is not about uh, if the law should allow, but if it does allow. Can you see that? Again, another example. Yeah? So any amount of inflation is bad for the economy. Okay? So the second premise. Last month, inflation was running at annual rate of 10%. Okay? Number three, this month inflation is only 7%. It's clear. And then the conclusion is very funny. The economy is on the upswing. Okay? So even the premise which follow is only that the rate of inflation is slowing down. Okay, the inflation is still occurring, okay, but more slowly than before. So this is very different from maintaining the economic, maintaining that the economy is improving. So it actually suggests the opposite of the conclusion. We already see. Okay. There are also semantic fallacies. Right? Semantic fallacies, depending on the content, the meaning. Okay? Semantic fallacies result of the language employed to construct the argument that has multiple meanings, or excessively vague in a way that interferes with the assessment of the argument. Let's take an example here. All factories are flat. All plants are things that contain chlorophyll. Therefore, all factories are things that contain chlorophyll. If you look at the form only, this is correct. You see, all PRQ, all QRR, all PRR. This is exactly correct. If you just look at the form, okay, correct, valid argument. Okay, but what is the problem here? It's the meaning of plant. Okay, because the meaning of plant have ambiguity, right? One is about plant means factory, the other one plant is actually the trees. Okay, so and they mix it up together. Okay, so yeah. Now after you understand the meaning, okay, it's actually okay, like this. And you see, so all factories are plants, so it's you're supposed to say all P are Q, right? And then all plants are the things that contain chlorophyll. Then the argument is supposed to say that all R are S. There is no because this plant in the second premise is not Q, right? Okay, so this is if you put it into form, which include the meaning, then this is supposed to be the form. Is it clear or not? Okay, so this is clearly again another example. It is silly to fight over mere word. Discrimination is just word. It's silly to fight over discrimination. Okay. Again, double meaning. Right? The word discrimination have two meanings. One is action or policy based on prejudice. Okay. The second is discrimination itself, which is to distinct. Right? And they mix the two words together. Okay. So this is clearly policy. So next is the type of fallacy, okay, which is based on the false premise. Okay. Now we have two types. Okay. One is called false dichotomy. Okay. This is a fallacy committed when we make a false assumption, okay, that only one of the number of alternatives holds. Second is called slippery slope fallacy. It occurs when the conclusion of the argument rests upon the alleged chain reaction, is suggesting that single step in the wrong direction will result disaster or undesirable result. Okay? So let's take some examples. Here, this is the example of false dichotomy. Either you are with us or you are against us. Again, this is from many leaders. Actually, George Bush is not the first one to talk about this. The Mongol Genghis Khan is also doing the same. So, premise two, you are not with us, then you must be against us. So, this is false dichotomy, isn't it? Right? In many contexts, the first premise can be false. Okay, there is a what is called the third option, which is neutral, isn't it? So they are forcing you to be either with us or against us. How about the neutral? Okay, it's not put there. So The reasoning itself is perfectly correct. Okay, be careful with it. The reasoning is correct. Okay, the argument is an instant of disjunctive syllogism, and therefore this is valid. Okay? If you just check the form, this is correct. Okay? Okay? And the premise is quite relevant to the conclusion, right? Okay? What is the mistake in this? Is the falsity of the first premise. Okay? If you check the relevancy, yes, this is correct. Okay? If you check the form, this is correct. Okay? What make it wrong? Okay? Okay, the one that make it wrong is the first premise is incorrect. Okay, next. Okay. Those who don't fight communism help along. John is not fighting communism. Okay? And then not fighting. Not fighting. So I just typed this. So John helping the communism. So this is again false dichotomy. You can see this is either yes or no, right? Okay, so yeah, P1 is false because this is dichotomy. Okay. Now, next is the example of slippery slope. Now, look at this. P1, if you step on a crack, you break your mother's back. If you break your mother's back, you commit a moral outrage. Okay. Number three, you should not commit a moral outrage. Therefore, you should not stop. So, again, one of these premises is false. Okay, so, you remember in the logic, if then, okay? In if then, so when it will become false. If A and B, A, B, A, B. Okay, 1, 1, 0, 0. Okay, 1, 0, 0. Then 1, 0. So this is the premise. This is the so if the premise is true and the conclusion is false, then this is so the premise is false in this case. Cannot see. Where is my picture? Oh, okay, sorry. Dave cannot see. He did not protest. Wait. How to how to remove that picture of the camera? Nothing. Maybe. Okay. Now. Yeah. Oh, Dave, can you see? Is it possible to see? Okay, he said yes. Let's go to the next screen. Okay. So this is another example. It's very long. Okay. So If all come back to the old trick, Mary will certainly go away too. If Mary go away, then Sue will certainly accept her job offer and move to Chicago. Number three, if Sue go to Chicago, her best friend will go away too. Number four, if they go, then eventually every single person will abandon the old brick. That's the name of the house. Okay. Number five, we should not allow that to happen. This is the conclusion. Right? All should not come back. This is policy. Can you see why? Can you see why? So, yeah. Suppose every single person will eventually abandon the old brick for some reason, okay? Regardless the power. Then the conditional premises would be all true. Okay? We may also agree that the last premise for the sake of agreement is also true, yet the conclusion still be rejected. So if all decision is not going towards the inevitable exodus from that house, then perhaps it's coming back with the best. Actually. So again, based on this, the change of our feeling, okay, and that will create a fallacy. This is called slippery slope fallacy, right? You see that? Okay. So another one, okay, this is also happen often. Is called you get bored already. Okay. So inductive fallacy. Okay. Inductive fallacy occurs when the probability of the argument conclusion given the premise okay, is very low, at least less than the actual. So example of inductive fallacy is faulty generalization that we discussed earlier, right? And another one is Gambler. So let's discuss the Gambler fallacy. Uh, this is the form of Gambler fallacy. X has not occurred recently, thus X is likely to happen soon. So the reasoning is fallacious if X is a designated type of event whose occurrence are more or less independent. Okay? So the actual event is independent, but they make it into the gambler in this case make it into dependent. Okay? That often happens. So then you can say this is called gambler. Let's take an example. On each of the last 10 rows, okay, the coin has come up head. Okay? So the conclusion is if we toss again, it's almost certain it will come up tail. Okay? Because it's already come up head for 10 times. Okay? The next probability should come up tail. Isn't it? So again, there are so many fallacies. You can check the Wikipedia. Okay? I did not even discuss some of these fallacies. Okay? So up to here, is there any? Dave, any question?
No questions, sir.
No question. Okay. How about you, Charles? Do you have any question? Okay. If you have no question, let's go to the third slide. Then you check in Mentera. Okay. This is about accuracy and something. Okay. So I hope by the end of this lesson, okay, you will be able to distinguish between accuracy and precision. And you will be able to compare distribution qualitatively, not quantitatively. Huh? Okay, let's discuss for precision versus accuracy. Okay, say a child was told by the mother to buy good matches. The child bought and tried and then tried all the matches. Okay, and then concluded that it was good matches. So the child gave the empty box to the mother, and of course the mother was mad. Okay, so what's wrong with the child logic? Is the child wrong? No, right? So so what's the problem? The mother's word is interpreted good matches. Okay, okay. So this is the problem. Is actually called precision versus yeah uh, accuracy. Okay, so this is a problem of sampling. The child logic does not know what is the meaning of sampling, so they get uh, he or she get the entire population rather than just check one, right? So here it is. Okay? Accuracy okay, refer to how close the measurement to the true value okay, or the accepted value. Okay? While the precision refer to how close the measurement of the same item are to each other. Okay, look at this drawing. Okay? This is low accuracy, high precision. You see, they are close to each other, right? But the target is in the middle. So they are not accurate, right? But they are high precision. Okay? How about this? This is low accuracy, low precision. Okay, this is high accuracy near the center, the target. Okay, but the spread is quite big. So in this case, uh, high accuracy, low precision. Okay? So this is what is called high accuracy, high precision. So can you conclude something from this? How do you measure the accuracy and how do you measure precision? When we said how close a measure, how close here, it means distance, isn't it? Right? This is a measure of distance. Okay. So one way to measure this variation, okay, how close to each other, okay, is called standard deviation. Do you know what is standard deviation? Have you learned? Okay, let me write it down here. Okay. So if if you have your measurement, I call this xi. Okay, xi means 1 point here. Okay, and then now if you sum all of this measurement, so I will use symbol xi, sigma I, which is the sum of the x measurement. Okay. Actually, we will use this. Okay, so this is called sum of xi. Okay, what you will do if you sum all of this of the measurement. Oh, okay, so what do you get? You said how close the measurement from each other. Okay, so then you will say, okay, I need certain value to compare, right? What is the value you want to compare? So you will say, I want to compare to the mean. Okay, so and then you take this sum. What is the result? What is the result? Oh, let's try. You want to try? Let's do an experiment. Okay. Okay. Numerical experiment. Okay. Open your Excel. So that you will not get bored with all the fallacies. Right. Let's do an experiment. Open your Excel. Can you still see? Okay, I create an Excel. Okay. Can you see? Can you start? Okay, let's create a random number. Okay, random between 1 to 100. Okay. Okay. So, let's create a data. Okay. So copy. Okay. Let's copy. Yeah. So I have this data. All this data here. You see? Look, data. I type there data. You see or no? Okay, I will make it so that you can see. So I have all this data here. Okay, and enter. This is my data. And look, every time I press F9, it will change the value because it's random, right? Can you see it or not? Dave, can you also try? Where is it? Is Dave still there? No? Yeah, I have the recording. Okay. So this is called xi. Okay. And this is the I. I is from 1, 2, 3, 4, and 4. I have 8 data. Can you see that? So this is the I. I is just the number, right? Of the data. Okay. Xi is the random value. It's clear. I keep in. Can you make it? Okay. Now I was asking the question a while ago, right? If you sum of xi minus the mean, okay, of x, what will happen? That was my question, isn't it? Okay. So how to get the mean? Okay, let's make the sum and get the mean in here. Mean is the average. Okay. Okay, so let's take the sum, okay, of this one, of the data, right? See, sum of the data, and I get the average of the data. equal average of data. Okay, this is like the top. Okay, so the average of the data is, for my case, I got 45.5. Press again, oh, different value. Huh? Every time I press, it will create different sum and different output, isn't it? So it's not so interesting because it keeps changing, isn't it? Correct? But I want to get, so this is called sum of deviation. Okay, let's do it deviation first. Deviation, deviation. What is deviation? Okay. Deviation is basically xi, okay, minus x bar, okay, average of x one. Okay. So how do you get that? Equal this one minus the average. Okay. You see? So because the 15 there, D15 does not change, so I anchor that with a dollar symbol so that it will not change when I copy. Can you? Oh, wait. Okay. Confused. Okay. Okay, confused. Which part you still confused? Only this. Okay. Do you know how to copy, right? Yes. But when you want to copy, you copy without changing. Do you know how to copy without changing? Okay, let me show you so that I will. Okay. So if I copy this is the first one is I put like this, right? D5 minus D15. If I copy this, what will happen? Look, yeah? I copy this, okay, here. Okay. What happened? See, this is D5 minus D6 minus D16. Okay, which is not in the data anymore. That's not what I want, isn't it? Again, if I move here, what is this? D7 minus D17, right? So this is not what I want. What I want is only minus D15. So 15, the D15 here, the 15 does not change. If you want something that does not change, in Excel, you do anchoring. Yeah? How to anchor? Just simply put dollar. Okay. How you know? Okay. So if you put dollar here and then you copy, what will happen? Okay, you see, okay, it will it constant, right? D15 always. Okay, so this is correct. This is what I want. Clear, yeah? Okay, now let's do the sum, right? What happened to the sum of this? Sum of deviation, right? Oh, let's do the sum of deviation. You get miracle. Yes, you get zero. Okay, zero. Okay, so I will put pink color here, okay, because this is zero. Oh, ajaib. Right, miracle, huh? So amazing. Why the sum of xi minus mean of x equals zero? Why? And look, this is random, right? So I can keep changing the random number whatever it is, doesn't change. It's always zero. Where the position is? Oh, amazing. This is what called mathematics. Okay? It's the invariant, the thing that never change. That is interesting. Oh, question why? Why this is zero? Dave, did you try?
Uh,
What? Are you still in the hotel
yes, I'm still in the hotel.
and you did not bring your laptop?
No, it's from my tablet right now.
Hmm.
Yeah, I don't know why.
Oh, you don't know why. So anyone have opinion why it becomes zero? Is this interesting? Why it becomes zero? Look, the sum of deviation, right? Let me write it down here. Not in the slide, but you need to know. The sum of deviation is always zero. Okay, this is the conclusion, isn't it? Oh, you have the case, you generalize. Right? This is not faulty generalization. This is correct. Okay. Then you need to prove that. Why? Okay, now the answer is simple. Yeah. The meaning of average. Okay. Why? Because this is the meaning of average. Exactly. This is the by definition. Yeah. What is the average? Average means the balance. Can you see? Okay. Left and right. Okay. You can be like this. You can be like that. So the 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 meaning of average is okay. Look at this. The sum is can be positive and negative. Right? That means on the left side or on the right. Okay. So the sum of that is always zero because that's exactly the meaning of average. Right? So okay. If you want proof mathematically, no. Okay. 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 Now it's important to understand what is called standard deviation. Have you ever heard standard deviation? Yes. Okay. What is standard deviation? Standard deviation. Okay. In Excel, it's very simple. You just do okay, that's the right, standard deviation of the data. Let's see. Okay. STD. This is not the standard deviation here is STDEF. Okay, so you can put the STDEF T, the same thing. Oops. Okay, of this data. Yeah, so this is the standard deviation. You get confused? For the data? No, for data. Right? This is the standard deviation of the data, not for the deviation. Okay. So, okay, if you want to get the standard deviation, right? You want to calculate standard deviation. Okay, let's get that number. How Excel do it? Right? You want to see what is inside. Okay, you already get this deviation. Right? So what you need to do is to average to 12. Okay, so you get this one deviation, okay, multiply by again this one, okay, and you copy, and then you take the sum, okay, and then you take the square root. Oh no, you divide by n. Okay, this one you divide by the number of data, which is the count of the data, okay, and then you take the square root. Oh, exactly the same. Oh, yeah, yeah, I will. You still don't confuse, okay. I will give you the formula, okay, so that you can get the meaning. Let me insert one slide. Okay, do it in here. Okay, so, oh, this one. Okay, let me finish this. Okay. So, you have your data xi, correct? Now, suppose your mean, your average, I call it mu. Is it okay? So minus with mu. Mu means the average of the. So what is mu? Mu is actually the sigma, okay, of xi divided by n. N is the number of days. Okay. So this is called D is deviation. Okay. And you know, a while ago we can prove it using Excel that the sum of D, okay, because this is I will put I here. Okay, the sum of DI is equal 0, right? Okay, so we cannot use deviation by itself. Okay, so how I will measure some spread, right? The precision is about the spread of the data, right? So how I will measure that? Okay, to measure that, okay, there are many ways. So one is to so that will not become 0, okay, is to put deviation square, okay. So in that case, I will have, okay, sigma of deviation square, correct? And then because this is also average of the deviation square, okay, so I divide again by n, right? Why you divide by n? So that if your data is so many, the deviation becomes so big, isn't it? Right? So if you divide by n, that means per data. Correct, yeah? You get the meaning, right? Divide by n means the deviation per data. Okay? But there is a problem. Why? Because I square it, yes, it will not become 0, but because I square it, the unit from centimeter now become centimeter square. I don't want that. From meter now become meter square. You don't want that. I want to come back to the actual unit. So that's why you take that. So this is what is called standard deviation. Oh, now you understand what's the meaning of standard deviation. Okay, now with this you can create do it in Excel, right? Okay. This is okay. Okay, so let's do it in Excel the same, yeah. So this one, okay, this is D, right? Okay, so I'm going to put it here. So this is D I, okay, D I. So this is D I square. Okay, so multiply by itself, correct? Okay, and then what you will do after that you sum, correct? This is the sum of DI square, in that formula. Okay, so again, yeah. standard deviation, you have di equal to xi minus mu. Okay, and then di square, okay, and is of course xi minus mu square, right? So di square, what you will do with this, I will sum. Okay, so I will take the sum of di square, but this is an average, so I divide by 8, right? So this is the sum, and then the average means I divide by the number of data. Okay, so if you confused with that, I will put n in here. N is what? Count, right? The count of this data. The count of data is called n. Okay, in this case 8. So I will put here divided by this 8. Okay, and then so now you have this, the sum of the I divided by n. Okay, this is already deviation square per data. Of course, now you need to take the square root, so that the unit becomes correct. Right? Then I take the square root here. Okay, square root of it. So you will get exactly the same as the Excel formula. Okay, clear. Okay, there's one more magic. Do you want? There's one more magic. Okay, is it okay? You have other classes, no? One more magic. Okay, so this is super magic. Okay, so xi, so this is the deviation, right? Now I divide, okay, di divided by sigma. Okay, sigma is this one, yeah. I will call this sigma. Okay, standard deviation. Is that okay? So I will have di divided by the sigma. Let's call this sigma so that we can put here sigma. Okay, so I will put this not that square, the di only divided by sigma. Okay, and I click here. Okay, di divided by sigma. Okay, what happened to this? I will put here. I take the sum of this new. Oh, exactly 0. And one more magic. This is the last one. STD, standard deviation of this. Oh, 1. Magic, right? Now, you don't believe me? Look, I made the random data random. It's always 0 and it's always 1. Look, this is 0, the same, yeah? It's just a computer problem, right? The error is very small. Okay, 0.00000 until 16. Okay, this is called machine error. Okay, so this is practically 0. Yeah. So, magic. Uh, this is called Z value. Okay. Okay. Interesting, yeah? And it's always happen, okay? This is mathematics, okay? It's always happen, okay? In any measurement, yes, in any measurement, whatever measurement you have, okay? Magic. Okay, so here, okay, let me write it down again here. What we just did, okay? Z equal to xi minus mu, this is the deviation, divided by sigma. Okay, and okay, the z, the sum of z, the area, right? The sum of z is always equal to 0, right? Okay, and the standard deviation of z right, is always 1. This is called normal. Okay? This formula is called normalization, statistical normalization. Any data, okay, if you take the mean, if you know the standard deviation, okay, you will always get 0 and 1. Always, yes, always. Okay. Again, this is fact. This is not opinion. You can prove it on your own. Okay. Okay. So today's lesson is until here. You cannot get or which ask question. Need more time in what? Okay. How about you, Dave? No problem because you are online.
No, just surprised.
Surprised that the z value is always 0 and 1,
Yeah.
the mean and the standard deviation. Okay. This knowledge is called statistics, yeah? Basic statistics. You will learn later on. Maybe Miss Indri will be the one who teach you that. Okay. Is there any question? If you don't understand, tell me the question so that I can get feedback from you. It's just a surprise or you don't understand at all? Oh, pity me. Oh yes, I will put this recording in YouTube. Okay. Uh, it's not public anyway, so even if you put your face, not public. Okay. So I will close the recording.